Hey guys, today we're going to look at modeling quantities and talk about accuracy with measurements. All right, the state standards that we're going over today use units as a way to understand real-world problems, use appropriate quantities in formulas, converting units as necessary, define and justify appropriate quantities within the context for the purpose of modeling, and choose an appropriate level of accuracy when reporting quantities. All right, so success criteria, this will tell you if you have mastered the lesson. So once we go through the lesson, come back and make sure that you can do all of these things. All right, the vocabulary you're going to need to know for this lesson: ratio. A ratio is a comparison of two quantities. Here's an example. The value of a ratio, AB equals A over B. All right, so this is the symbol for ratio. The values of equivalent ratios are equivalent. So if these two are equal, then they would be considered equivalent. A proportion is an equation stating that two ratios are equivalent. A rate is a ratio of two quantities used in different units. Precision is the level of detail of a measurement, and accuracy refers to how close a measured value is to the actual value. Make sure the vocab is in your notes. It'll make it easier to refer back to when you need to review these. All right, guys, let's look at a few examples. The first one says complete 0.552 milliliters into how many liters? All right, so first on the EOC practice sheet or the reference sheet, you're going to be given some conversions. So it'll tell you that 1,000 milliliters equals 1 liter. So let's go ahead and write that down. So we got 1,000 milliliters equals 1 liter. All right, if you don't know that and you don't have a reference sheet, you can Google how many liters or how many milliliters in a liter, okay? And it will tell you. So once we have that, then we just have to set up our ratio. So we're going to have 0.552. That's in milliliters, so we're going to put that over 1,000. Equals, this is our unknown. We don't know what that is, so let's call it X over 1 liter. Cross multiply, so we're going to have 1,000X equals 1 times anything is that number, so 0.552. Divide both sides by 1,000. All right, so this number is going to get smaller. But if you don't know which way to move the decimal, go ahead and type it in your calculator, 0.552 divided by 1,000. In the calculator, it's going to show up as 5.52 e to the minus 4. That means it's in scientific notation, and that means you have to move this 4 places to the left. So you're going to move it 1 place, and then you have to add 3 zeros as placeholders. So it's going to be 0.000552. So your answer for this one would be C. All right, now number 2, same kind of problem. So we're going to have 343 milliliters over 1,000 milliliters. We don't know how many liters yet, but we know that's over 1 liter. So we're going to have 1,000X equals 343. Divide by that number because you're solving for X. And see what you got there. So we're going to have 343 divided by 1,000. Again, you're moving your decimal 3 places. So it's going to be 0.343. So this is going to be answer D. All right, guys, the next example says the north building of the World Trade Center is 1,368 feet tall. estimate how many yards tall it is. All right, so hopefully you know that 3 feet equals 1 yard. All right, if you don't know that, again, Google will help. All right, so we're going to have 1,368 feet. So we're going to have that over 3 equals, estimate how many. So it's going to be an estimate, so it's going to be close to this number. And then over 1. So we're going to have 3x equals 1,368. Divide both sides by 3. X equals, all right, let's look at our calculator here. All right, 1,368 right here divided by 3 equals 456. All right, so it says estimate, okay, so it means close to, 44,400 1/4. So 400, C, is going to be your closest answer. That's your best estimate. All right, number 4, if a clock ticks every second, how many times does it tick in a year? All right, so you have to know a little bit about time, okay? So let's write down what we know. We know that there are 60 seconds in 1 minute. We know there are 60 minutes in 1 hour. Hopefully you know there's 24 hours in 1 day. And there's 365 days in 1 year. All right, so we want to go. If a clock ticks every second, how many times does it tick in a year? All right, we can see that these are all in scientific notation, but first we just need to see what we get. So all we have to do is multiply 60 times 60 times 24 times 365, because all these are in units of 1. So if we multiply these units together, we are going to get our answer. But again, we're going to have to convert it to scientific notation. So 60 times 60 times 24 times 365. All right, so that's going to give us this number here. Remember, scientific notation is a number between 1 and 10 times 10 to some power. So if we have a number between 1 and 10, it's going to be 3.1536. Okay, let's see if that's to the 7th power. So it'd be 1, 2, 3, 4, 5, 6, 7. So that is going to be your answer here. C will be the answer for number 4. All right, the next example. Ewan is mixing a bag of nuts, sesame seeds, and raisins for 24 children at summer camp. She used 2 3/8 pounds of cashews, 1 1/2 pound of walnuts, 2 1/4 pound of roasted peanuts, 1 1/8 pound of sesame seeds, and 1 3/4 pounds of raisins. How many ounces of mix can Ewan put in each bag so that each child has the same amount? Okay, so the first thing you need to notice is all of these units are in pounds, but it says how many ounces. So the first thing we need to do is how many ounces are in a pound. So 16 ounces equals 1 pound. All right, so then we have to look and see how many total ounces we have, and then divide that by the number of kids that we have. So 2 3/8 pounds, let's start with the whole number. 2 pounds is how many ounces? 2 times 16, so we're going to start with 32 ounces. And now I need to convert 3/8. Well, 8 goes into 16 twice, so that's the same as 6 over 16. Remember, 16 ounces in a pound, so all we need is the numerator. The 6 tells us how many ounces that is there. All right, we're just going to keep adding because we got to figure out how many total ounces we have first. So we can say this one is checked off. Okay, got that one. Now we need 1 1/2 pounds. 1 pound is 16 ounces. Let's go ahead and add 16 ounces here. And then 1/2 pound. Well, 1/2 of 16 is 8, so 8 ounces. So we got that one. That one was easy. All right, now we've got walnuts. 2 1/4 pound. 2 times 16 again, so we're going to start with the whole number, 32 ounces, plus 1/4 a pound. All right, 4 goes into 16 4 times. So 4 over 16 is the same as 1/4. So we need to add 4 more ounces. Excuse me. Now we've got 1 1/8. So 1 pound again is 16 ounces. And then we have 1/8. 8 goes into 16 twice. So there's 2 more ounces we need. So we got this one. And then the last one is 1 3/4 pounds. We know that 1 pound is 16 ounces. Go ahead and add the whole number. 3/4, again, 4 goes into 16 4 times. 4 times 3 is 12. So 12 more ounces. All right, so if you want to add these up, you should be able to just kind of add these up here. We can go 32 and 6 is 40, 56. I'm just going to throw this in my calculator real quick. I can do this in my head, but it is late and I'm getting tired, so I'm just going to add them up here. All right, let's see. I'm actually going to pause it. All right, sorry, I think I kind of paused that mid-sentence trying to save time on the video here. Anyways, I added those numbers up. I got 144 total ounces. It says how many ounces can you input in the bag? So each child has the same amount. So 144 divided by 24 kids gives us 6 ounces. So each child will get 6 ounces of snack for the correct answer there. All right, the next question, a box of spaghetti weighs 1 pound. Lindsay cooked 9 ounces of spaghetti. Will she be able to make another meal of equal size with the remainder of the box? All right, again, 16 ounces equals 1 pound. If she cooked 9 ounces of spaghetti, we can subtract 9 ounces, and that means she has 7 ounces left. She cannot cook another meal of equal size. So the answer to that would be no. She would need at least 2 more ounces to cook another meal of equal size. All right, the next example says the formula for converting degrees Fahrenheit to degrees Celsius is C equals 5/9 times F, which is Fahrenheit, minus 32 degrees. Find the equivalent, so find the equal amount of Celsius temperature when the temperature is 50 degrees Fahrenheit. So all we have to do is take 50 degrees Fahrenheit, substitute it in, and solve for C. So we're going to have C equals 5/9, 50 minus 32. And then we have C equals 5/9. 50 minus 32 is 18. Let's take our calculator and figure out what is 18 times 5/9. So 5/9 times 18 is 10. So 50 degrees Fahrenheit is 10 degrees Celsius. All right, in the formula, W equals negative 39 plus 3/2 T. W is the approximate wind chill temperature when the wind speed is 20 miles per hour, and T is the actual air temperature. Find the approximate wind chill temperature when the actual air temperature is negative 5 degrees Fahrenheit. Okay, that's the temperature, and the wind speed is 20. Okay, so it already says this is the formula when it's 20 miles per hour. So again, all we have to do is take the negative 5, plug it in for T, and solve for W. So W equals negative 39 plus 3/2 times negative 5. So W equals negative 39. This is negative 15 over 2, which is negative 7.5. And then I'm going to add those together, and I get negative 3946.5. So the wind chill temperature when the wind speed is 20 miles per hour is negative 46 0.5.